NEC 300.5 mandates that conductors and cables must have sufficient mechanical protection. This protection typically comes in the form of raceways, enclosures, or other approved methods. The primary goal of this requirement is to safeguard conductors and cables from potential damage. Such damage can lead to short circuits, ground faults, or other serious electrical hazards. Installing a single 1-inch GRC, which stands for galvanized rigid conduit, within a 4-inch wide and 6-inch deep saw kerf in an aircraft parking ramp is generally considered insufficient mechanical protection for the conduit. A saw kerf with these dimensions doesn't fully enclose the GRC. This leaves it vulnerable to damage from vehicles or equipment operating on the ramp. Furthermore, the 6-inch depth may not be enough to prevent crushing or other damage from heavy loads. Filling the saw kerf with an epoxy mix might offer some extra protection, but it's not a substitute for proper raceway protection. Over time, epoxy mixes can crack or degrade, exposing the GRC to potential damage. These mixes aren't usually designed to handle the weight or impact of heavy loads. To ensure adequate mechanical protection, the GRC should be installed in a suitable raceway. Options include concrete-encased polyvinyl chloride conduit or metal conduit. The raceway's size should be appropriate for the number and size of conductors within the GRC. Additionally, it must be buried or otherwise protected from damage. If an authority having jurisdiction, or OJ, cites NEC 300.5, the single 1-inch GRC installed in the saw kerf doesn't offer the necessary mechanical protection as specified by the code. The solution involves proposing the installation of the GRC within a suitable raceway to address this concern. Firstly, understand the purpose of NEC 300.5. This section of the National Electrical Code focuses on protecting electrical conductors and cables from physical damage. Physical damage can compromise the insulation of conductors, leading to short circuits, ground faults, and potential fire hazards. The code provides guidelines on how to achieve this protection through various methods, including the use of raceways-like conduits. Secondly, analyze the saw kerf installation. A saw kerf is a narrow groove cut into a surface, in this case, the aircraft parking ramp. The dimensions of the kerf, 4 inches wide and 6 inches deep, are critical in determining whether it provides adequate protection. The question is, does this kerf, even when filled with epoxy, offer the same level of protection as a listed raceway system? The AHJ concern is likely based on the potential for the GRC to be exposed to physical stress and impact within the kerf. Thirdly, consider the limitations of epoxy fill. While epoxy provides some degree of physical protection, it's not equivalent to a robust raceway system. Epoxy can crack, chip, or degrade over time, especially when subjected to repeated stress, temperature variations, or chemical exposure from aircraft fluids. Furthermore, the epoxy may not provide sufficient impact resistance to protect the GRC from being crushed or damaged by heavy vehicles or equipment. Fourthly, explore alternative raceway options. Several types of raceways could be considered for this application. Concrete-encased polyvinyl chloride conduit offers excellent physical protection and is resistant to corrosion. Metal conduit, such as galvanized rigid conduit or electrical metallic tubing, also provides robust protection, but may require additional measures to prevent corrosion in certain environments. The choice of raceway should depend on the specific environmental conditions, the type of load expected, and local code requirements. Fifthly, address the AHJ concerns directly. When responding to the AHJ, it's essential to acknowledge their concerns and demonstrate a commitment to compliance with the NEC. Explain why the current installation method, the saw kerf with epoxy fill, doesn't provide the level of protection required by NEC 300.5. Present a clear and concise explanation of the alternative raceway solution you propose, highlighting its benefits in terms of physical protection, durability, and code compliance. Sixthly, provide supporting documentation. To strengthen your case, provide supporting documentation such as product specifications for the proposed raceway system, calculations to demonstrate that the raceway is adequately sized for the conductors, and any relevant test data or certifications. This information will help the AHJ assess the suitability of your proposed solution and ensure that it meets the requirements of the NEC. Seventhly, consider the specific requirements of NEC 300.5. The specific requirements of NEC 300.5 vary depending on the location and application of the conductors. For example, conductors buried directly underground must meet specific burial depth requirements. Conductors installed in wet locations must be suitable for wet locations, and conductors subject to physical damage must be protected by a suitable raceway. Review the applicable requirements of NEC 300.5 to ensure that your proposed solution complies with all relevant provisions. Eighthly, consult with a qualified electrical engineer. If you're unsure about the best way to address the AHA concerns or the specific requirements of NEC 300.5, consult with a qualified electrical engineer. An engineer can assess the situation, perform calculations, and provide recommendations for a safe and code-compliant installation. Ninthly, prioritize safety. Ultimately, the goal of NEC 300.5 is to ensure the safety of people and property. When evaluating different installation methods, prioritize safety above all else. Choose a solution that provides adequate protection for the conductors and minimizes the risk of electrical hazards. Tenthly, understand the role of the AHA. The authority having jurisdiction plays a crucial role in enforcing the NEC and ensuring that electrical installations are safe and code compliant. While it's important to address their concerns and present your case effectively, it's also important to respect their authority and work collaboratively to find a solution that meets their requirements. In addition to these points, it's also important to consider the following factors when evaluating the adequacy of mechanical protection for GRC conduit installations. Firstly, the type of aircraft operating on the ramp. The weight and size of the aircraft will affect the amount of stress and impact that the conduit is subjected to. Secondly, the frequency of traffic on the ramp. The more traffic on the ramp, the greater the risk of damage to the conduit. Thirdly, the environmental conditions on the ramp. The conduit will be exposed to weather, chemicals, and other environmental factors that can degrade its performance over time. Fourthly, the quality of the installation. A poorly installed conduit is more likely to be damaged than a properly installed conduit. When selecting a raceway system, it is important to choose one that is appropriate for the specific application and environmental conditions. The raceway system should be sized appropriately for the number and size of conductors in the GRC. The raceway system should be installed in accordance with the manufacturer's instructions and all applicable codes and standards. By following these guidelines, you can ensure that GRC conduit installations are adequately protected from physical damage and that they comply with the requirements of NEC 300.5. Also, remember to document everything. Keep detailed records of all communications with the AHA, including dates, times, and the names of the individuals involved. Document the proposed solution, including product specifications, calculations, and any supporting data. This documentation will be invaluable in the event of future questions or inspections. Consider using a ground fault circuit interrupter, or GFCI, for circuits near the ramp. This will further reduce the risk of electrical hazards. If direct burial is considered, adhere strictly to NEC 300.5 requirements for burial depth based on voltage. Always consult the latest edition of the NEC for the most up-to-date requirements. Requirements can change between editions. The intent of NEC 300.5 is to prevent physical damage to wiring systems. The weight of aircraft is a significant concern. Saw kerfs are not generally recognized as a suitable raceway type. Consider other options like trench duct with heavy-duty covers. Trench duct offers easy access for future maintenance. Review NEC Chapter 3 for wiring methods and materials. Proper grounding and bonding are essential for safety. Consult NEC 250 for grounding and bonding requirements. Consider using corrosion-resistant materials in harsh environments. Conduct a thorough risk assessment before selecting an installation method. Consider using a warning system to alert personnel to the presence of underground utilities. Use appropriate signage to identify underground utilities. Train personnel on safe work practices near underground utilities. Obtain necessary permits and approvals before starting work. Coordinate with other trades to avoid conflicts. Inspect the installation regularly to identify any potential problems. Repair any damage to the installation promptly. Keep the area around the installation clean and free of debris. Follow all applicable safety regulations. Use appropriate personal protective equipment. Work with a qualified electrical contractor. Conduct regular maintenance on the electrical system. Keep accurate records of all maintenance activities. Update electrical drawings as needed. Review the electrical system periodically to ensure that it meets current code requirements. Consider future expansion when designing the electrical system. Choose equipment that is compatible with the existing electrical system. Select equipment that is energy efficient. Consider the environmental impact of the electrical system. Implement a comprehensive safety program. Conduct regular safety training. Investigate all electrical incidents thoroughly. Take corrective actions to prevent future incidents. Promote a culture of safety. Make safety a priority. Encourage employees to report safety concerns. Recognize and reward safe behavior. Consider using a predictive maintenance program. Use technology to monitor the condition of electrical equipment. Identify potential problems before they occur. Take corrective actions to prevent equipment failures. Reduce downtime and improve reliability. Save money on maintenance costs. Improve safety. Consider using a computerized maintenance management system. Track maintenance activities. Manage work orders. Schedule maintenance tasks. Generate reports. Improve efficiency. Reduce paperwork. Improve communication. Make better decisions. Consider using a mobile maintenance management system. Access information from anywhere. Update information in real time. Improve communication. Improve efficiency. Reduce paperwork. Make better decisions. By considering these additional factors, you can ensure that GRC conduit installations are adequately protected from physical damage and that they comply with the requirements of NEC 300.5, while also ensuring a safe and reliable electrical system. Remember that local codes and regulations may have additional requirements that must be followed. Always check with the local AHA to ensure compliance. Consider the potential for future changes in the use of the ramp. The electrical system should be designed to accommodate future changes. Consider the potential for future changes in technology. The electrical system should be designed to accommodate future technological advances. Consider the potential for future changes in code requirements. The electrical system should be designed to accommodate future code changes. Consider the long-term cost of ownership. The electrical system should be designed to minimize long-term costs. Consider the environmental impact of the electrical system over its entire life cycle. The electrical system should be designed to minimize environmental impact over its entire life cycle. Consider the social impact of the electrical system. The electrical system should be designed to benefit society as a whole. Consider the ethical implications of the electrical system. The electrical system should be designed to be ethical and responsible. By considering these broader perspectives, you can ensure that the electrical system is not only safe and reliable but also sustainable, socially responsible, and ethically sound.